Hey guys, it's Peter from the Mentors here, and welcome in the 6th episode of our Building FeedR Microservices series using .NET 6.0. And within this episode, we are going to make use of the gRPC. So the gRPC is one of the, let's say, transportation layers built on top of the HTTP2, which we can use to actually provide this way of communicating our services with each other. And you might be wondering, all right, so why would I actually need to use gRPC instead of, for example, just plain REST API or maybe WebSockets? So there are multiple reasons why you might think considering gRPC. Now keep in mind that the gRPC isn't really there to take over the REST API. So you should rather treat this as an alternative, not like a replacement. Of course, you could possibly build your whole API around the gRPC and even use tools that will, for example, translate kind of automatically your gRPC services and endpoints to your, for example, REST API endpoints. So you could pretty much connect these both worlds with each other. But typically from the consumer perspective of your API, most likely you are going to stick with the web HTTP based, for example, RESTful API or maybe JSON-RPC API anyway. But when you need efficiency, when you need, for example, lightweight framework, when you need, for example, a way to stream the data very efficiently, when you need to have a high performance within your services, and whether this is going to be your end API consumer talking with your system, or whether this would be your microservices talking to each other, you might give gRPC a try. So the gRPC is kind of an open source general purpose framework for building this RPC, which stands for the remote procedural call services. And this is very good technology because it's very mature, well established, it's fully open sourced, and it's been adopted by multiple languages and frameworks out there. So it doesn't matter if, similar to, let's say, HTTP API, classical REST API, it doesn't matter if you are using .NET, Java, Go, Rust. If you want to connect them with each other, you will be able to do it very easily. So it's very efficient. It's using binary serialization. So it's built on top of the protobuf as this underlying serialization mechanism, which makes it more, let's say, much lighter than plain JSON. But again, this is not human readable. So the JSON is human readable, it's human friendly, but the binary serialization is not really human readable, not really human friendly, but it's, let's say, computer friendly because it's going to use less space than the plain text JSON serialization, and it's going to be more efficient, faster. And like I said, there are like multiple reasons why you might think of using gRPC. And one additional reason is that with gRPC, you are going to declare your contracts under these files. So you can simply share these files, the so-called proto files, with the consumers of your API, and then just by using the tools built into the framework that they are going to use, once again, whether this is going to be .NET, like in our case, Java, Go, any other framework that is out there, they could automatically generate the client for your service so that they don't need to write pretty much any line of code. So something similar like what you could achieve, for example, when working with the Swagger and some Swagger tools around this open API schema that could generate automatically your HTTP clients to talk to Swagger or open API based REST APIs. So this is what we are going to work with in this episode, and let's see how we can build our very first console, so simple yet fully working consumer for one of the services. Alright, so here we are at the gRPC IO website, where you can find a very nice documentation with lots of samples, including the C# code. For example, here you could just take a look at their samples and how you can build your first gRPC service. So one of the reasons that we might want to actually stick to gRPC, as already mentioned, is that because it's a binary serialization, it's very fast, very efficient. You can work around the streaming capabilities, which is really hard to achieve when using just typical web APIs built on top of the HTTP. And if you want to have, once again, if you want to have, for example, strongly typed contracts for your services within the gRPC. You just declare these files, these proto files, where you declare your service definition, your methods, your data, and then you can provide such contract to your consumer, and then this person, the developer working on this implementation for, let's say, integrating with your system, will only need to receive this public service definition, and the code will be automatically generated for this person. So that's really cool. So there's a lot of benefits of the gRPC, as we already mentioned. But keep in mind that it's not like maybe a replacement for the REST API. The REST API still has its place, and I'm pretty certain that this will be a still valid solution to build the REST APIs for many years now, and it will be like a valid solution for many years to come, as it's been for many years now. But gRPC is a really nice alternative, which might make your system even more, let's say, more mature, more fancy, and maybe more efficient if you would like to work around some kind of either public APIs for efficiently streaming the data, or when you think about your internal services communication, whether this will be your services streaming the data internally, or just using the gRPC capabilities, strong contracts, binary efficient serialization to talk to each other synchronously instead of plain REST API calls between them. So let's take a look how we can use the gRPC in our code. So as you can see, what we have here is our console client. So let's assume that we would like to get some data using gRPC using the console client. It might be console client, web service client, desktop client, mobile client, any kind of an application written in one of the available languages out there. So they're like Java, Node, Rust, lots of languages that you can use with gRPC to communicate using this protocol. So let's assume that we want to build a very simple console app that will be able to get the data, for example, to start with from our quotes. So in our quotes, we already have this pricing generator, which generates some data, and we are already streaming this data through the Redis Pops app. But let's assume that we like to, for example, be able to talk to our service using the public endpoints. So let's assume that the Redis PubSub might be internal for our services usage, for our infrastructure, but the gRPC endpoint, just like the REST API endpoints, might be publicly exposed for our system consumers. So what we are going to start with is by providing this Protos file definition. So into our FeedR quotes and under this pricing, let's keep it separated. So I'm going to add this directory. I'll just follow the convention. So I will add this Protos directory, and here we'll start adding our contract definition for our gRPC service. So I'll make a new file here, and I'll call this one something like pricing.proto. And I'm going to start with the definition of a service. So the syntax will be proto free, and then the C# namespace for our service will be the following. So I'm just using some additional features of the ASP.NET Core here, of the .NET and gRPC integration. So the namespace for our C# will be the actual namespace of our pricing service. So let's say the FeedR quotes.pricing. And then let's provide here also the package name if we want to stick to convention. So the package under which we are going to, let's say, package our gRPC internal call will be, let's say, pricing protos, which is the name of the directory, and then protos as the subdirectory under which this file does live. And now the important part, so our service. So let's start with the service definition, and I will call this, for example, the pricing fit. And in our service, I'm going to declare to start with a single method. I'll call this get symbols. So let's say we want to make this classical request response call to get some data from our web service. So here I need to, besides my method name, I need to provide some parameters. So let's say I will provide here something like get symbols request, right? This will be my data, my request data, and then it will return some data as a response. So let's say a symbol response, like this, right? Or symbols response. So now let's declare our message contract. So here I'm going to declare my get symbols request as a message, and this will be empty, right? So I could also use the built-in gRPC empty type, but for now I don't care. If I want to put some data here, if I want to provide some maybe parameters for filtering my data, pagination, and so on, I can provide them here. I'll just leave it empty for now. And the response from my symbol will be the following. So let's say I'll have this message. I will call this symbol response. right? Or I can also call this something like get symbols response, right? Whatever we call this, just be consistent with the namings. You would find something like request and response or replied. You would just find something like the DTO's namings. So just pick your convention and just stick to it when defining your gRPC services. So there's a request object, which is empty. There's a response object, and I want to return the array of my symbols, which will be just a strings. So I could do something like string symbols, right? Or string symbol and then equal 1. And this means the position within our gRPC data contract, because this is serialized using binary serialization, using the protobuf as the serialization schema. The protobuf has this requirement to position by using this indexer these particular properties. So it's important that we don't just change later on. Let's imagine we'll have something like a long value here, for example, like this, or not long, or actually int, let's say 64 value, let's say at position 2. So it's important that we later on just don't swap this with something like 1 and 2, because if the person using the contract provided by us, the public contract definition, would still use the previous version with the actual values like this, 1 and 2, right? This person would get some issues when trying to deserialize this through the protobuf. So it's important to not really mess around with your positions. If someone is already using your contract definition, just to gradually upgrade, gradually version your API definition, because it's using the binary serialization and it's used by the protobuf behind the scenes to actually put these specific properties under the positions for this serialization later on. This is one of its features and has to be done in the right way without messing around with this position properties, with the property of these positions, position of the properties, sorry. So the response will simply return a list of symbols, and in order to make it an array and a collection, I'm going to provide this keyword called repeated. So we'll have just a collection of string called the symbols, and this will be the only property which lives under our gRPC message contract. So let's try now to implement our service. So what I'm going to do is that within our FeedR, let's under services add a new class, and I'll call this pricing gRPC service, just like this. And this class will simply implement or derive from this pricing feed service. So now let's just rebuild our app and let's take a look at our C# project file. So here you can see that I have included this gRPC ASP.NET Core, and I included this as a reference to our code. And one more thing that I actually need to do in order to, let's say, resolve this proto file from our project is to provide an additional protobuf item group. So I need to do something like item group, and then here I will specify this is a protobuf, all right, protobuf, and then include, and there a path to our file, which is going to be pricing and then protos and then pricing.proto. And then I need to specify what will be the service type. So in our case, we are the producer, we are the server type. So I will specify that I want to generate the code to actually implement the server side of our gRPC, to actually implement the code not as a client, but as a server, which is able to override and implement those methods, for example, to stream or just return the data in general. So I'll make this gRPC services equal to the server. And if you were to, let's say, start a new project by just calling something like add new project, and then let's say ASP.NET Core and gRPC service here, then you would get this file generated automatically and all these definitions. So we are doing this manually so we can understand what's going on behind the scenes. So we have this package, we have this protobuf item group include here with the gRPC services set to be server. And now let's try to rebuild our app. And let's see what happens. So if we rebuild it, and if we jump back into our background service now, into our gRPC service, what I can try to do now is something like derive from this pricing feed, as you can see here, and then the pricing feed base. So if we take a look, this is the automatically generated compiled code by our gRPC services, by our gRPC tools, which are part of this ASP.NET Core gRPC package. So this is what happened behind the scenes. So the framework picked up, the compiler picked up that we have this proto file included with this gRPC server capabilities in place, and it generated the code for our server side. So what I can do now is simply, I could override, and we have this method getSymbols here, And there's our request and the context, the context of our call, something like HTTP context or HTTP request scope of our server-side request call. So here I can simply return the data. So what I will do now is, in order to return some data, let's just jump back into our pricing generator here, and let's just expose this method returning a list of just collection of strings, and I'll call this get symbols, just to make sure we are getting some valid data. And within our generator, I will simply just return these keys from my dictionary. So I have these 4 symbols, 4 currency pairs in place, and I'm just going to return this currency pairs and then keys. So this will be my symbols list. And what I can do now is I can jump back here and I can just inject my iPricing generator. Now keep in mind that the lifetime scope will be per request, let's say per connection of our client. But if you want to make it a singleton, like a gRPC service to be a singleton scope, you can also change it. But by default, this will be scoped by the, let's say, request, the gRPC request sent by the client to our server, similar to, let's say, the scope lifetime for ASP.NET Core middleware, which is scoped per unique HTTP request being sent from the client to our web API. So I'm going to inject this pricing generator here, and I'm just going to return the data. So this is like a task that I can implement any kind of invocation there, any kind of method body within this get symbols method. So I'm going to simply, since as you can see, this is just a synchronous call, I'm just going to simply wrap it internally within the task, and then from result, and I'm going to return, as you can see, this get symbols response. So there is our data, once again, our message contract automatically generated based on our proto file definition here, right? And we have this symbols property. So let's take a look. If I jump back here, there's our symbols. So I can simply assign this symbols, and I'm going to assign this to my pricing generator get symbols. So this is just a list of strings, and this is how I'm going to return my data from this call. All right, so this should look fine. This is what we can do here. There's our symbols list. Let me just make it a bit more of a one-liner code like this. And if I like to get some data from my request, since this is automatically generated here by the gRPC tools as well, if I were to put some properties in here as well, I could actually just, call something like request and then, for example, dot, and I would find these properties here, which I could pass, for example, to filter out my symbols or to make a call to create a user, start a feed, whatever I can think of. So that's one important thing. Now let's jump into our program CS. And within our program CS, what we are going to do is we are going to simply, at first, call this add gRPC. So we can do something like services and then somewhere down below, add gRPC, because you can see it has additional extensions there. So add gRPC. And then I'm simply going to call something like app and then map gRPC service and then provide our pricing gRPC service instance. So our type of our gRPC service instance component. So this is what I need to actually map my gRPC. Now important part, depending on the OS that you are using to build and start your services, since I'm building here it on my macOS machine and it doesn't support some important, let's say, features when it comes to the TLS and HTTP certificates internally on its own server, what I had to do here within our app settings, I added this Kestrel extension, this section for configuring the Kestrel. So I'm going to run my web API under 5040 as we did before, like this, but I'm going to expose my gRPC under 5041 using HTTP2 as a required protocol transportation layer, because this is what gRPC uses behind the scenes, but I'm going to expose it using HTTP, not HTTPS. So whenever you run gRPC services, you need to run them using HTTPS. You want them to be secured using TLS, and all the security encryption stuff. But in our case, since it's macOS and it doesn't support and this TLS feature is required to run gRPC under HTTP2, like for example on Windows where you can install this self-signed certificates easily, I'm just going to run this, but only for the local development purposes in this unencrypted HTTP2 mode using the plain HTTP schema, not the HTTPS without the TLS. So this is the only change I need to do. If you were to run this on Windows, you should be just fine. Similar if you were to run this, for example, on the Linux. But keep in mind that when you publish your microservices, you're most likely going to publish them either to Windows Server or Linux Server. So this won't be an issue, and you can run your gRPC as you should run using this encrypted HTTPS, HTTP2, transportation layer. So you'll be just fine. So that's our server side. So I can of course run my server side, run our quotes up, and let's see what happens. So we have now port 54 and then port 5041 for our gRPC services. So as you can see, and that's okay, it's all good. And now let's try to build our client. So we have this console app, right? We have a very simple console app, and into this console app, we only install these three packages. So this protobuf, gRPC.NET Client, and gRPC tools, so we can build our client around this protos contract definition. So this does nothing for now. It just shows the hello world message. So now let me just copy this public service destination for our gRPC services from this quotes microservice, and let me just paste it here. And let's see. So we need to have the same definition of our contract, right? This is our, let's say, public file that would exchange, that would expose to the consumers of our services, of our, let's say, API gateway later on. So let's take a look. Our app, our FeedR client's console, it already actually, determined that we have some protobuf file definition here. So it already added, this proto definition there. But just remember, we need to change this from the server side to the client. So no longer gRPC services of the client type, but the gRPC services of the server type. And if you want to make it simpler, I can simply just take this definition from here and just swap it with something like, for example, this client and then protos and then pricing proto. And this will be pretty much the same. Important part is to just change it from the server side to the client side. And let's try to implement our client, our very first method to get this data for our symbols, right? To call this method somehow from the client perspective. So what I can do now is the following. So I'm going to instantiate a new channel for our gRPC services. So let me make something like channel, and then we have this gRPC channel for address. So I'm going to hard code this for now, and the address of our microservice. So localhost 5041. So we'll be hitting our gRPC service exposed by the cache row endpoint using this unencrypted HTTP schema without the TLS. So it's HTTP2, but using this unencrypted HTTP schema. And then once we have the channel, we can instantiate our client. So I want to have a new client, and let's see, we have this pricing feed client now. So once again, based on this proto definition, since we said we want to have this protobuf included into the project, but with the services of a client type, this will generate a client for our console app. So I can provide my channel here. And now let's move further. Let's do something like console write line. And then let's just simply type press any key so that the user knows what's happening, any key to get symbols. Okay, and then let's just do console read key to wait for any input, read key, and then when we want to get the symbols, what we can do, very simple stuff. I can do something like, let's say, symbols response, and then await. And let's take a look. We have our client, so I can call get symbols async, and then I need to provide my data, so new get symbols request. And since we have no additional properties there, I am just going to instantiate a new instance of this object, and there should be my response. So if the response is valid, I can, for example, iterate. So for each symbol in the symbols response symbols, let's just simply console write line the symbol. So we have the symbol as a string, and let's see if this is going to work. So now I'm going to start our quotes microservice, and let's start our console app. So maybe I will run it through the console, through my terminal. So let me just navigate to the clients, and then to the console and our console client, and I can simply do .NET run. And let's see what's going to happen. So click, and there is our data. If we take a look at the logs, let's see, we can see that we have executed this endpoint gRPC get symbols, and then our service return the data. So if I run it once again, no issue. I can just click it once again, and there are my symbols once again. All right, so easy stuff. Now let's think how we could actually stream the data. So we are already streaming the data from our background service, from our quotes microservice through the Redis PubSub to the aggregator microservice, which we did in the last episode. So we have this streaming between the quotes and aggregator microservices using Redis PubSub. But here, what I want to do, I want to be able to, let's say, stream data to my client. So later on, we could, for example, try to expose this gRPC easily through our gateway, through our YARP API gateway by extending configuration here for the gRPC support, which is built into the YARP anyway. So this could be easily done. So now I want to expose this public API so that also the clients of my solution can listen, subscribe to this, let's say, currency pairs data, right, as a real-time or almost real-time data stream. So now let's jump back into our quotes and let's extend our definition for the gRPC file. So here under the protos, what I'm going to do is I'm going to provide here one more method, and I'll call it something like subscribe pricing, and then let's say pricing request, right? So there will be my request to subscribe to this pricing, and then I want this to return the stream. So you can see there's this keyword called stream, and then let me just call it something like pricing response. Okay, so of course I need to provide these two additional message contracts down below. So the first one will be pricing request, and to this one I will also add optional property called symbol, so we could filter our pricing stream by the specific symbol or just subscribe to all the pricings. And the pricing response message will be pretty much the copy of our currency pair object, which will contain the symbol, value, and a timestamp. So I'm going to do something like symbol at position 1. Now the value, and keep in mind, we don't have the decimal support here. We have only double. So if you are working, let's say, with the values of your currencies, if you're working with something which has to be precise, you could rather easily, for example, extend the gRPC with your custom decimal type. We are not going to do this now, but you can easily check how this can be done. It's really easy stuff to extend, for example, with custom type by providing the custom extensions into your gRPC services and into your .NET Core code, into your C# code. So I'm just going to do things much simpler. I wouldn't say that's what you would do in a production environment, but that's close to it in some way. So I'm just going to provide our value, our currency per value as an integer. And let's say I'm going to multiply our decimal value, which might contain, for example, 2 decimal points by 100, so that on the consumer side, I can divide it by 100, just to, let's say, keep things simple and still have this kind of decimal precision almost in place. So there's our value, and then there's our timestamp, which is a long value, and this will be placed at the position number 3 within our data contract. So our definition looks good. So now let me just copy this guy. Let me just copy this updated service definition, and let me put it here. And also let me just fix this namespace, since it should be actually our console app namespace. So let me just fix this guy here and rebuild the solution. Yeah, so let me just do it, and let me just provide this proper namespace now. All right, so we have this additional method for responsible for streaming the data. So what I can do now is something like jump back into our gRPC service, and then within our gRPC service object, our component, what we can do is we can override our subscribe pricing method. So here, let me just make it a bit cleaner. As you can see, we have our request, right? So there's our request, for example, symbol we provided. We have our stream. So within our stream, we can just call write async and send back the data stream to our consumer, and the same server call context. So now the question is how we can actually somehow push the data from the generator to our gRPC service, which runs under some different lifetime, which of course is not related to our HTTP context or request scope. And of course, it runs under a different lifetime, which is different from our background service, which is a singleton running, let's say, in the background thread, somewhere in the background of our app. So there are like numerous ways of how we can achieve it. And one of the ways I will show you will be the following. So since I don't want to start my generator here internally, because theoretically I could do something like a wait for each, and then I could just start my generator here internally. So I could do currency pair in generator start async, but we mentioned that the generator should be started only once, right? It should be started only once within the background service, and the background service is starting it here. It's ensuring that this is not, let's say, manipulated by different threads, and it can be only started and then stopped by stopped once at a time. So this is responsible for generating this currency pairs values, right? This next ticks as the time goes on. So I don't want to do it this way. So I want to somehow publish my data from my background service, maybe to my gRPC service. So what I can do is the following. I could, for example, extend my pricing generator, which gets a bit bigger, and probably we could even make it a little bit cleaner and just maybe split it into two separate interfaces. But to keep things simple, let's assume that I'm going to expose here the following event, this plain old C# event, returning our currency pair as an object. So I'll call it something like pricing updated, and I'm going to add this event definition into our pricing generator, somewhere here into our component. And what is going to happen now is that whenever we'll update our value, so somewhere here, right, when we are updating our value, I'm just going to call this pricing updated and then invoke, so question mark dot. So if there is no subscribers, I don't want to fail with the null reference exception. So if there's any subscriber for this specific event, I'm just going to invoke this with our currency pair value. All right, so this will be invoked every time. This event will be invoked every time. And then internally within our pricing gRPC service, what I can do is the following. So within our method, which is here, I can do something like this. I could subscribe, for example, to this event, pricing updated. All right, and then let me just create here a new method. I'm actually going to make this an internal method. So somewhere down below here, let me just make this a local function there. So I will call this on pricing updated. And to meet this event handler, C# event handler specific definition, I just need to provide here the sender and our currency pair as our, let's say, currency pair value. And so I can subscribe to this method, right? Like this, using this good old C# events and event handlers, stuff. But the question is, all right, so how can I stream this data, right? Because somehow I need to stream this data further to my end user. So I could subscribe to this method here, or I could subscribe to this method, somewhere here. So what I'm going to do is the following. So I'm going to make this while loop, all right? And so unless the client drop the connection, so I can check. So until this is cancellation requested is false, so as long as the client is there and the client didn't drop connection, I want to stream the data to this specific client. Now what I'm going to do, so how can I actually somehow get this data, let's say from this event handler method definition, and push it further? Because I can push it further using this response stream, write async. So I need to somehow to get this data and then, pass it here. So I can do this quite easily. So I can declare, for example, since this is scoped per unique, let's say, connection request from the gRPC consumer to our server side gRPC service, I could use the blocking collection. So for our currency pair, I want to have this, let's say, currency pairs collection. Let me call it this way. And what I can do, so whenever our pricing generator sends us this pricing updated data, I can simply add this to our blocking collection. So I'm just going to call this currency pairs and then try add, and simply add this additional currency pair to our blocking collection. And then internally within our while true loop, what I can do is something like if if our currency pairs try take. So if I cannot take my currency pair, all right, I'm just going to continue. So there is my broken collection. It will just wait until the data is there, right? That's the purpose of this collection. So if data isn't there, we'll just continue. But if the pricing data is there, or actually if our currency pair data is there, I can just stream this data. So I can do something like write async and then new pricing response, and then I can simply map it. So the symbol will be our currency pair symbol. The, let's say, timestamp will be our currency pair timestamp. And finally, the value will be our, let's say, integer value. So let's say 100. So I'm going to just, make this multiplication between these two. And then I can do something like this, which, like I said, is not like what you would do in a production environment, most likely. But this is what you could do, for example, here in order to make it work. So this is what we could actually do, and of course the currency pair dot value to send this data further. So the issue or the challenge was that we have this background service being responsible for running or actually managing the only single instance of the generator, which starts this subscription or which starts this data generating feed somewhere here and pushes the data, streams this data through the Redis, pops up to other microservices, and we still wanted to be able to somehow react to these data changes, but from the gRPC service perspective. So I cannot really inject my gRPC service here because it lives under the different scope of the gRPC connection. So we simply added this event here, and then we subscribe to this event within our gRPC service. And when the connection happens and when the client asks for the pricing feed for the currency pair data stream, we'll simply hook up to this event through this event handler definition. We'll add this to our internal blocking collection, and then we will just keep this while loop for as long as the client is present. So let's say if the connection is gone, we could just remove this event handler, this hook to our event, right? So just to clear out this no longer valid event handlers. And maybe let's put some logging there in place as well. So let me just do something like iLogger for our pricing gRPC service, logger, and then let me just log here something like logger log started client streaming and log information, of course. And then we can do something like here, let's say stopped client streaming, right? So the client gets disconnected, we can stop it. Of course, we could also wrap it with some additional try-catch blocks. So if there are any errors, maybe we would like to clean up something, remove something, whatever. This is a method that you can implement. You can inject the stuff here. So just, you can do pretty much anything you want within your gRPC service definition. But just like with the controllers, you would rather keep this, method small, rather clean, rather transparent. You want to really, let's say, decouple this from your application or domain logic. You would rather inject some services, command handlers, dispatchers, some kind of mediators to, let's say, send these commands or queries to the other components. So you simply just call some component, get data, send data, save data, publish an event, and you delegate this application or business logic to the specific layers and components. So you only orchestrate what should be done, but not how it should be done from your gRPC perspective, like you do from your controller's perspective. And one more last thing. So we have this additional parameter to be able to filter by the symbol our pricing feed. So I can do something like if our symbol isn't empty, so if within the request the symbol string value isn't empty, and if our, let's say, request symbol is different than the pricing symbol with our currency pair symbol, so if these two are different, we don't want to, let's say, send this data. All right, so we can filter by the symbol, but if we don't provide any symbol there, we are just going to receive all the symbol data on our client's side. So this is what our server side might look like. And now let's take a look at our client side. So once again, jump back into our console app of our client. And here, let's do something like, at first, let's do the console write. So we have this very just awesome logging mechanism using console write line, or actually console write maybe. And let's do something like provide a symbol or leave empty, like this, all right? And then we can do provided symbol equals, and then console, and then read line, and then to upper invariant, just to make sure that we have sent the proper symbol to the server, the gRPC service, and then we can do some basic validation or even while loop. So let's say if the provided symbol by the user isn't empty, and let's say if this symbols list doesn't contain the symbol, so let's say if this symbols response symbols contains symbol is false, this provided symbol, then we could while loop until the user provides a valid symbol or an empty symbol or just for an exception, whatever. I'm just going to, let's say, write something like invalid symbol, and then the provided symbol is invalid. So let me just do it this way. Provided symbol is invalid, and then I'm just going to return or log some error, whatever. But if it's a valid symbol, I'm going to do something like pricing stream. And then let's take a look. We are going to call our client, and we have this subscribe pricing. So we have this method once again generated based on our proto service definition. So let's take a look. Subscribe pricing. I'm going to provide our pricing request. So there's our pricing request once again, being part of our pricing proto pricing request definition. So let's jump back into our console app, our client console, and there the symbol will be our provided symbol, so either empty or a valid symbol from this console read line of code. And then what I can do is simply, while the data is there, so I can do while await pricing stream, response stream, move next. Okay, and the cancellation token will be none. But if you were to run this from, let's say, other asynchronous methods, you can pass down this cancellation token. So you can, let's say, disconnect from the server. So we could, ignore, cancel your ongoing stream from your client perspective. And then we can actually grab the data by simply reaching and grabbing the data from this pricing stream, response stream, current property. So this will be our current data, our current currency per value. And then let's just do console write line, and let's write our data. So for example, I'm going to write the following. So we are using this epoch timestamp. So I will do datetime offset from Unix time milliseconds and the timestamp. So the current timestamp. And then let me just do something like the symbol. So there will be our current symbol, and then the value will be our current.value. And then, like I said, if we're using this 100 multiplication, I can do something like divide by 100 and then with this fixed point value, which is not, of course, ideal, but just to give you a glimpse of how this could be potentially done in some other places. But ideally, we will just probably extend this pricing proto definition with our custom decimal type, just to make sure we are not losing any decimal points, any values, because this could have very dramatic consequences when it comes to some kind of money fintech solution. So yeah, that looks good. Now let's try to run our apps and let's see if we can make it work. So I'm going to run our currency generator, our pricing currency per generator. So the quote service is already there, and let's run our console app. So let me just do the following. Let me just grab this here and let me run the first instance and let's see. All right, symbols, and then if I leave it empty, let's see what happens now. So there is our started client streaming. As you can see, there is no data yet because I didn't start my generator yet. But if I start it, so if I make this call to my CodeRes file, to my CodeRes endpoint, let's see, and the data is there. The data starts appearing. So I'm streaming my data for the PubSub to the aggregator using the Redis PubSub, and I'm also streaming my data here to our public consumer for the gRPC. If I disconnect, not an issue. You can see that the consumer has been disconnected here, but of course the server still works. I can run, let's say first instance, and then let's say the second instance. So now I want to run two consumers. So the first consumer, let's say, will subscribe to this your USD, all right? And let's say the second consumer will subscribe to, let's say, your gBP. And let's run the third consumer that will subscribe to pretty much anything. So there's a second consumer and then the last consumer. And there it is. We have 3 concurrent consumers. Let's say the one for the USD, one for your gBP, and the one subscribing to all the data. We have our Quotes microservice and streaming all the data. And if I want to, I could even now run my additional service. So we could run our, for example, aggregator microservice, which is also consuming this data, but using the Redis PubSub as different streaming mechanism. So we could keep the Redis PubSub for internal purposes. We could, for example, keep the gRPC for the external, for the public consumer purposes, but also for the internal microservice communication or data streams. But the thing is that, well, as you can see, the gRPC when it comes to .NET is pretty much a built-in major solution. It's been out there for many years now. The gRPC in .NET is very, very efficient, as you can check in some of the benchmarks. One of the most efficient, one of the fastest in the world implementation of the gRPC framework. And yeah, just if you want to try it out, you have all the tools you need. You can see how easy it is to work with the gRPC. Of course, it might get tricky with something like the load balancing. Just like you would load balance your HTTP requests, it gets tricky with the gRPC load balancing. But there are tools and there are solutions to work around this challenge. So yeah, that's pretty much it. And hopefully you'll find maybe in one of your apps the good usage of the gRPC protocol. Okay, so that's all for this 6th episode. Hopefully you enjoyed building your gRPC services. As you can see, very easy stuff, very easy to use, very mature technology, lots of features, built-in features, lots of support across different frameworks and languages. And yeah, just before you jump on into this bandwagon and start using your gRPC instead of the REST APIs, just give it a good thought. But whenever you see this applicable and whenever you think of some efficiency, performance, or maybe data streaming, this might be a very good choice for your next communication mechanism. So that's it for this episode, and thanks for watching. See you in the next one.